Hello and welcome to my channel. I'm Bound to Be Coding, and this channel is about a single-player 2D survival game hobby project that I'm working on called A Struggle to Survive. It's set in 1820 America during the time of the beaver trade and the Rocky Mountain rendezvous. If that piques your interest, I invite you to subscribe to this channel and follow along in my dev blog. You can find a link to the blog here on my channel. If you find this video interesting or helpful, please consider liking and subscribing. I really do appreciate your interest in my game. As you can see, I'm developing my game in the Godot game engine. As of this video, I'm running Godot 4.2.1 stable. Today I want to talk a little bit about my inventory system and what makes for a good inventory system design. And so let's get started. I'm going to first start by launching the game and kind of giving you an overview of what my inventory system looks like and how it works. This is my inventory system. It is designed to be dynamic and to build containers and items inside of containers in a parent-child relationship. So I have the ability to create these inventory windows. I can add items to those inventory windows. Each window is a container, and double clicking I can open up my backpack, for example. I can drag items over into the backpack. I can also double click and open up other containers. I can drag items from one container. This one is a keg of gunpowder. I can drag it, put it over here in my large powder horn. I open up the powder horn. I can see that it's now, excuse me, full of gunpowder. Let's see, what else can we do? We can sort the containers with their respective inventory items. We can drag and drop items that are allowed to be in a particular container. This is an Indian parfleche, and I can drag some jerk meat into it or some pemmican into it. Double click and open it up, and I have my items. Also display weight. I can display in standard or metric. Let's see. The windows themselves, these containers, the window is dynamically constructed in code. So I just define what this pouch looks like, how many slots it has, the size of slots that it has, and then from that, when an instance is created, it's built dynamically. So this window is actually the same as this window. The difference is the slot definition for the window itself, the container, and the name at the top. The functionality is the same, and that's what you want in any kind of system. You want to be able to build a system that's dynamic, that is controlled by code, not so much controlled by how many scenes you are placing and how much code you put in the code behind of your scene. So this window is a scene and this window is a scene, but they are built dynamically, and I'll show you that in just a few minutes. I have three slot sizes in my inventory system: large, medium, and small. And I also have the capability to support containers, obviously, and also items, which these are items. And I also can support liquid. So opening up a container, this wood bucket, it contains 125 units of dirty water. I can open that up. I could open up this tin cup, which is a container, drag the dirty water over, drop it in. The sound effects are relative to how much water is being moved. So a little bit of sound effect for a little bit of water, and more sound effect or a longer sound effect for more water. I can also, for any given container, we have two child containers here in the backpack, I can open this guy and it will open up both of the containers that are inside this container, which is inside this container. I can also set the position of each one of the containers, and I can lock them into position so that when I open them back, they open up in the correct position. And all of this configuration that I'm doing, moving the windows around, things like that, um, will be saved out to JSON files in my game. So just showing you how this works. Okay, so that's basically inventory. There's tons of other features in it. I won't get into it because really this video today is about design. How did I go about designing this, and how did I make it extensible? How did I make it to where I could just go in and edit some data and create new items and have those items appear in the game? That's what this video is all about. And I think what I'll do now is just basically take a look at a very, very rough sketch of my design and show you a little bit about what you're seeing here on the screen. Okay, so what are we looking at here? I just put together a rough sketch in Paint.net. Excellent editing tool, by the way. It's free, and I have used it for years. I love it. It's great. I do all my art in Paint.net. I highly recommend this program. There's a lot of others out there, and I do use other programs, but Paint.net is, yeah, it's my go-to editing tool when it comes to art and drawing and things like that. So I just threw together this game inventory engine design concept visual to kind of go over the inventory system and how I designed it. So we have, of course, our file system, which holds, that's where we store our PNG images, the JSON definition files, the JSON saved data. The file system is when you go into Godot and you take a look at it, and you look here and you see your file system, and here's where all of your files, your scenes, your images, your sounds, everything is stored there. And so in game design, in designing the game, of course, we're going to be creating files that are going to sit in the file system. Now in my game engine, or excuse me, inventory engine, the way I designed it was I created a singleton, an inventory engine singleton. Now that singleton is a script. That script is auto-loaded. Oops. The script is auto-loaded in my project. So you can see my inventory engine here. And for those of you that don't know, and by the way, I'm going to gear this to very beginner level overview of this engine. What I'm trying to do, what my goal is here, is to try to teach some folks that don't really have a whole lot of background in software design. I want to just impart some knowledge. I have been doing this for a long time, not game development, but software engineering. I have almost 20 years in software engineering, and there are design principles that just flow right into what I'm doing in this hobby project. And so I'm adapting those principles, or using those principles that I've learned over the years in designing this game. It's a hobby project. I don't expect to make any money on it or anything like that. I'm just doing this for fun, really. I love development. That's why my name is Bound to Be Coding, because I love coding. I love writing code. Anyway, so we have the singleton, which is basically a single instanced class that gets loaded at the very beginning of the run of the project. It sits way up above all of these other windows, and it loads first. If I switch over to the remote here, whoops, let me close this, switch over to the remote, you can see that root level for the game, my engines are located above my main window, and they're always there. during the entire run of the program, these engines, these singletons are there. And so I created a inventory engine singleton. Now the purpose of that singleton is it holds dictionaries that are loaded from these JSON files. JSON is a data format, a file format for um, storing data. Very user friendly. You can open it up in a text editor. You can, as long as you form it right, as long as you know put your JSON data in the right format, you can do a lot with it. I chose JSON back in Godot 3 when I was working on this game in Godot 3. I used resource files. Resource resource files are fine. They work, but I found them somewhat cumbersome because, like for example, if I wanted to add, if I had a dictionary embedded in a resource and I wanted to add another item to the dictionary, it at least in Godot 3, it was very frustrating because I ended up having to recreate the dictionary just to add one more item to it because the user interface in Godot at that time made it very difficult to add something to a dictionary. I decided when I moved my game from Godot 3 to Godot 4 that I would switch from GDScript, resources, things like that, over to C Sharp, which is my language that I use at work and one that I'm very familiar with. And when I did that, I decided, well, I'm not going to use resource files. I'm going to go with JSON files because JSON files are very easy to edit. They're very easy to work with. They're very easy to load. They're just fantastic. And I use Newtonsoft's JSON library, um, and it is blazing fast. And I recommend Newtonsoft's products. So we have this inventory singleton here, which is the script that gets loaded at the beginning. It's always running, it's always there. And what that means is that I can always access it. Anywhere in the game, I can get to this inventory engine script. Okay, so the inventory engine loads the JSON files. It creates dictionaries for the uh, JSON definitions, and all my JSON saved data is also stored in a dictionary that then gets saved out to back to another JSON file. But the inventory engine, it is the heart of my inventory system. The code, most of the code is there. It controls pretty much everything that the engine does and can support. So all of my features that are specific to the engine are in this singleton script. It performs all the CRUD operations. Say, what is that? Well, um, create, retrieve, update, and delete. This is just an acronym that database developers uh, are familiar with. CRUD operations, creating records and retrieving records and updating records and deleting records. Well, all of those operations are operations against the dictionaries that I'm using to store my definition, my container definitions and my object definitions and my container instances and my object instances. The inventory engine controls all of that. And it also has the other inventory methods in it, like the sort that you saw earlier, and being able to lock the UI and have that persist into the instances of the containers, things like that. All of that is in the inventory engine. So I have my file system, I have my inventory engine singleton, and I also have the third part of this is my UI nodes. All right, my inventory window itself is a scene, and which is built on nodes in Godot. The inventory window, the inventory slots, the inventory window manager, the UI itself, all of these things are part of the user interface that is the scene structure in my game. Okay, so you'll notice here inventory slot, you don't see anything. Well, that's because I've laid out my UI, but the UI is controlled by the script that is attached to the top level node in the scene, and this script builds everything dynamically. The player window, It's a little different because we have a, oops, that's my inventory window. That's another window I'm working on. Um, this is my inventory window. Okay, this is the default layout for this for this window here. You can see all of the pieces of it, um, and of course you see all these slots. Now you don't see those slots in the scene itself, and the reason you do not is because they are dynamically added. I have these groups that I set up for large, medium, and small, and my script is responsible. The one that's attached to the inventory window scene is responsible for querying out to the inventory engine, getting the information it needs to then construct this window dynamically based on the definitions that are used. You notice I have these arrows pointing. So we've got some traffic going back and forth between the file system, the inventory engine singleton, the loading, and the saving. We also have some information flow between the inventory engine singleton script to the out to the nodes, and then from the nodes, the scenes, back into the inventory engine. So basically the UI sends requests to the engine, and the engine then sends responses back to the UI, whatever is needed, whatever's requested to send back and forth. Now, these these steps here they're not really steps; they're just points that I want to mention about game inventory design. Okay, so the engine loads the dictionaries, the UI requests inventory containers, the inventory window manager spawns inventory windows, and the inventory window loads the slots. Drag and drop on the slot itself, the mechanics built into the slot, calls into the inventory engine to process changes. So when the player, grabs an item and moves that item to another slot, the inventory engine gets called the inventory engine gets a request to say, hey, move this guy from this slot to this slot. And then the engine, of course, is responsible for taking care of it. And then, of course, the engine, once this drag and drop has taken place, the the engine, the engine then says, okay, inventory window, you have some different content. I want you to refresh. And so the inventory window then picks up a response from the inventory engine, and the inventory window says, okay, I need to refresh. So it goes out and it says, well, give me my data. What does it look like now? It has changed. And then of course the inventory window then rebuilds the inventory slots. And so these UI nodes are dependent upon each other. The top level nodes, whatever they are, then you get down to the inventory window manager, which is a node that a scene. I'm using node and scene interchangeably, but really a scene is just a combination of nodes. Hope you understand that. But the inventory window manager is responsible for controlling the inventory windows that are opened and closed. And the inventory window is responsible for populating the inventory slots. So there's responsibilities in each one of these components of this engine design. Okay. Now you'll notice I have this big X here and these arrows pointing from the file system to the UI. There really, in a good design, there really should be no communication between the file system and the UI nodes. Okay. Um, I say no. There are situations where you want to preload resources in the UI, and therefore in the code behind you're going to be loading something. But as far as this general game inventory engine design, the flow of information, the flow of transactions really should be what you're seeing here on the screen. I think it's probably a good idea right now. We are about 19 and a half minutes into this video to inject this thought, because I think this is important. It'll sure save me from a ton of responses to this video. Let me say that there are 1,000 ways to Sunday to do something in software development. Nobody has the best way of doing anything. If they do, it just means they haven't learned the next best way to do something. So please keep that in mind. This is a game inventory engine that I wrote. This is a design that I put together, and these are concepts. Okay? Game inventory engine design concepts. They're not set in stone. They there's there's dozens and dozens of different ways of doing things. I'm just trying to show you how I did mine, what made sense to me. If you need to spin something up yourself that's totally different from everybody else, that's perfectly okay if you have the ability and the skills to do that. If you don't have the ability and skills and you want to learn, okay, you clicked on my video, you wanted to learn about inventory and game engine design concepts for inventory, and that's what I'm sharing with you. But you'll get differing opinions from everyone, really, everyone that is passionate about software. So I just wanted to mention that. There's, you know, someone would look at this and say, wait a minute, you're not communicating with the file system via your UI. What's wrong with you, bound to be coding? Why aren't you loading resources? Why aren't you loading this, that, and the other? I am, but this is just a general concept for data flow. I think that the engine needs to call out to the file system to get what it needs. The only time really that we have any interaction with the UI nodes is when we are preloading scenes. We are preloading other, you know, nodes that we need to use that are based on files that are in the file system. Those are perfectly acceptable. But what I'm talking about is a game engine that is focused on, or excuse me, inventory engine that is focused on a good design for inventory. All right, I'll move on. So in the file system, you want to have as much code as needed, just as much as needed. You don't want to go overboard with code in your file system files. Okay, this is data. This is very little code is going to be sitting in my files that I'm loading into my singleton, my inventory engine singleton. So as a general concept for the file system, we're loading definitions, we're loading data, we're loading, and we're loading two kinds of data. We're loading static data, and we're loading, which is data that doesn't change, and we're loading instanced data, which is data that's created in the game that changes every time we open that game and we play it. And so we have both of those files uh, as as only as much code as needed. Now over here in the UI, we also want uh, as much code as needed, but we also, the principle is as little code as possible. The the there's a concept in software engineering called separation of concerns. You want to separate your code out so that you're you are placing code together that's related to code that's written together. What do I mean by that? Well, the inventory engine is where I should put all of my logic that is related to this engine itself. The code that I put in the scripts that are attached to these UI nodes, it's as little code as possible to manage the UI features. Okay, so we're gonna be wiring up drag and drop functionality. That's a UI feature, and so we want that code in the UI. Okay, we're not going to be implementing drag and drop functionality, which is a UI function, in the inventory engine. Likewise, we're not going to be manipulating the objects that are in our dictionaries in the UI nodes. Why? Because the UI doesn't care about that data. The UI just wants to render that data, render what is being pulled from the engine. The engine is responsible for that. So as little code as possible in the UI, just enough to get the job done. Okay. Now over in the inventory engine, you want as much code as possible. You want anything that can be abstracted away from the UI and the scripts that are attached to the UI, you want to put that in the engine. Now there's several reasons for that. Number one is the inventory engine only loads one time in memory. You might have 50,000 nodes. You don't want to put your code that manages your inventory objects in your UI. Then you're multiplying the amount of times your code is being loaded into memory. So that's one reason. The other reason is, and I know it's really, really hard to imagine, but you may stray away from Godot one day. Okay, I did. I moved from Unity to Godot, and I did it way before this current fiasco with Unity. I did it almost 2 years before that. Um, but you may move to another game engine, and if you do, you'd kind of like to reuse your code, wouldn't you? Well, if you put it in a singleton, in this case with Godot, into a single script, then you can, for the most part, um, reuse your code, especially if the engine you're going to supports the language that you're using, like in my case, it's C sharp. So you want as much code as possible in the singleton, in the um, so that you can take it with you if you ever decide to leave this engine and go for that engine, that type of thing. All right. So these are, you want as much code as possible. Now, one more comment on this little um, uh, drawing that I did here before I move into the code and actually show you how this all works together. The file system is going to tend to be game engine agnostic, meaning that these files are not going to change when you move to another game engine. So they are game engine agnostic. They don't care what game engine you're using. Okay. Whereas the inventory engine, it is mostly game engine agnostic. You know, the better design, the less code that is tied to an actual game engine, but it's going to be mostly game engine agnostic. And to show you what I mean by that, if we take a look at my code and we go to the inventory engine, this is my class for the inventory engine, you will notice that I inherit from Node. Node is a class that belongs to Godot. So is my inventory engine completely Godot agnostic? No, because I'm tapping into the engine to run my code, to do the things that I need to do that are specific to the Godot engine. But a large part of this inventory system is completely Godot agnostic. It has nothing to do with Godot, and I'll show you that. And then, of course, you've got the third piece, which is the UI, and it is completely game engine specific. This UI, these UI nodes, they will probably only ever run in Godot because this is where Godot, the Godot engine itself, is providing you the UI tools to implement the game that you're making. So, you know, it is game engine specific. So at the end of the day, you want most of your code sitting over here because that's where you're going to be able to reuse it in the future. Okay. Okay. All that said, if you have any comments, if you want to share with this audience any comments about what I've talked about in this inventory engine design, if you want to add to it, if you want to share some things, feel free to leave comments in the video comments. If you have questions for me, you can leave comments as well. But again, let me just remind everyone listening to this video, there's 1,000 ways to Sunday to do something. So don't beat up the deliverer just because you don't agree 100% with what I'm saying. I'm trying to help as many people as I can understand good engine design. That's my goal. That's all I'm trying to do. So take what I say and do your research, come up with your own ways of doing things, implement your systems, and hopefully when you do, you'll be implementing with good engine design concepts. So we're going to move away from this and go right into the code and take a look at some things to reinforce what I've said here. All right, this is my inventory engine script. It does depend upon Godot. It is inheriting from Node, and I've mentioned in this video already that I am using C# as my language. It is the language I work in day and out. at work, and it's one that I'm very familiar with. Um, and also, I mentioned earlier that I have moved from Godot 3 to Godot 4, from Godot 3 resources to Godot 4 JSON files, from Godot 3 GD script to Godot 4 C sharp. And you may wonder why I did that, and I'll go ahead and tell you. I alluded to it earlier when I said that the resource system in Godot 3 uh, was clumsy to work with in the UI, and so that's one reason why I decided to switch over when I wanted to port my game from 3 to 4. I wanted to kind of change it up a little bit. And you might wonder, well, why did I learn GDScript if I already know C sharp and I'm already familiar with C sharp? That kind of hints to the whole mentality of a software engineer. Software developers love to learn new things. Software developers love to learn and be introduced to new ways of doing things. And it's just, it's just in my nature to want to learn and to pick up skills. And so I decided when I went from um, Unity over to Godot that I wanted to learn Godot's scripting language because I wanted to be able to not only learn it, but in learning it, understand a little more about how Godot is designed. And then on top of that, I wanted to be able to read GDScript. See, there's a lot of code out there in the internet, on the internet. There's a lot of code out there written in GDScript, and I didn't want to be looking at GDScript and wondering what on earth is that. And I know the syntax is, looks to be a little Pythonish, like Python, but and I know that if you've been in software development and you've learned an object-oriented programming language, you can make your way through it, reading other languages and kind of get the gist of what's going on. But I really wanted to be able to read, especially when I'm elbow deep in developing this game in Godot. I want to be able to read those scripts that are written in GDScript and understand them. So that's another reason why I did it, just so that I could read. The other was so that I could write and write stuff in GDScript. And so reading and writing, that was my goal with learning GDScript. And then when I went from Godot 3 to Godot 4 and realized that Godot 4 offered the ability to use, .NET 7 and, excuse me, .NET Core uh, version 7, Net 7, Net 8, I realized that it was going to give me a lot of tools or a lot of the ability to use a lot of the new tooling in .NET. So I'm running Core 7 here, .NET Core version 7, and I'm going to be moving to .NET Core 8, eventually. So I want to keep up with the languages or with the language that I'm using at work. And so that was another reason. And then, of course, C Sharp is so much faster than GDScript. C Sharp is also more powerful than GDScript. There's a lot that you can do with C Sharp that you can't do. So these are the reasons why, I ended up going away from Godot 3 resources GDScript over to Godot 4 C Sharp. Now, let me say something about dictionaries. If you're not using dictionaries, I highly recommend that you do for your data. A dictionary is essentially a simple database. Each one of my dictionaries is a table. And if you've done any database work, you can relate to this. A dictionary is like a table in a database. I have a key, I have an object, which is the table columns that I am, the table and the columns. These are like databases. And so when I develop this inventory engine, I treat them like databases. Now I'll tell you what I don't do. I do not, from my UI layer, say, give me these 30 or 40 or 50 objects. For example, give me 50, give me the 50 items that are in this container. Give me all those items. Put them in an array and ship them over to the client. I do not do that. Well, first of all, that's a lot of data, right? And secondly, I'm I approach the design of this from the mentality of a database storing my game data and accessing that database via these dictionaries in a game in this inventory engine by using CRUD operations. So um, when I'm requesting the contents of a container, I am requesting only as much information as I need to query these dictionaries to give me the information I need to display in the UI. See, the the game engine, inventory engine, needs to hold and manage all of the data, but the UI does not. There's a lot in the dictionaries that I leave in the dictionaries in the information that's in the inventory engine, and I only pull back what I need, and that is really really important. And so so I start here with this my inventory engine, and if you look, I am right now I am at 1750 some odd lines of code. That's that's my inventory engine singleton, and that's where most of my code is going to be. All right. Sorry that this isn't quite as organized as some videos, but I just had this on my mind this morning when I got up, and I thought I'm gonna just throw this video together. So I'm sorry. I'm sorry I didn't put any preparation into planning for this, other than just kind of shooting from the hip. Um, okay, so where do I want to go next? Let's take a look at in the file system. Let's take a look at these JSON files and see what they look like. All right, so I have here in my solution a folder for resources and data, and these are my JSON files that I am loading into memory when I load in the inventory engine. Let's take a look at the container definition. And I suppose I should couple this. My domain, I have a container definition here. And so if you take a look at this, so this class is my container definition. Now let me inject here. My objects in my inventory system. I have three types of objects. I have containers, I have items, and I have liquids. Okay? That's just the way I designed it. I wanted to separate them out so that I could put some restrictions on containers as opposed to items, as opposed to a subtype of item called liquid. Okay. Now, this class, notice I have no references to Godot. It doesn't inherit from Node. This is pure C sharp, and this is what I was talking about when I said that the file system is engine agnostic. This is just C sharp. Okay. And what I'm doing in this class is I'm identifying what I want a container to be. I'm defining what a container is. Okay. And this is my definition, mine, the one that I came up with. Yours might be different, but the definition supports the features that I want to have in my game. Okay. And so this is the container definition. Now, the definitions are the static data. That's the data that doesn't change. So when I release my game, if I ever do, let me back up because who knows? I may not. I don't care. This is a hobby project. So rather than talking like someone that wholly expects that this game is actually going to make it to market, I don't care if it does or not, to be honest with you. Um, anyway, the data here doesn't change. So when I run the game, this container definition is not going to change. The JSON data that is loaded into this class, this container definition class, is not going to change unless I stop the game, go in and edit the files, make some changes, add some containers, new containers, things like that. Then run the game again. The container definition picks up the changes or the data into the dictionaries. Now this is what JSON looks like. All right. It's just a collection of these JSON, which is really simplistic. I will tell you now, if you go look at a resource file, Godot 3, Godot 4, look at a resource file. It isn't going to look like this. To me, and this is just my opinion, and in my mind, this is a whole lot easier to work with than a resource file. But I used it in Godot 3. I liked it. It was fine. It did its job. It did its job well. I had some UI related issues with, maintaining the data. I decided to go to JSON. I've never looked back. But if you like resources, hey, more power to you. Okay, they are what they are. They do what they do, and they do it well. Okay, so this is the JSON file for my container definitions, and I load these definitions into my inventory engine at the beginning when the inventory engine loads. So to add a new item, to add a new container into my game starts with a record here in this JSON file for the container. Now, the same is true with items. Items are the same way. Inventory items have an item definition. My item definition is very short and sweet, and it's all the static things about my inventory items that I want to record and store. Okay, that's the important thing. The definitions are static; they don't change. The instances, they do change, and the instances are what the engine creates. And so what I do is I tie my item instance, and I'll just jump over to item instance here. I tie my item instance to its definition. So you notice I don't have a key here. I I I may get into that, the reasons for that in another video, but this item instance, I currently don't need to have a key for it because it is keyed based on parent ID and parent slot of the container that it's in. Okay, and it's associated to a definition. So I can access the definitions in my inventory engine dictionaries. I can pull that definition in the engine to do things. The item instances that are supplied to the UI are very, very small pieces of data. Okay, and that's what you want. Your static data, you don't want to generate your static data 1,000 times. You only want to generate it one time. Your instance data, that's where you're getting into your copies of copies of copies of things, and your all the data that's going to be manipulated by your engine. So you have to think about, memory consumption, and if you can separate the stuff that doesn't change from the stuff that changes, you're doing good. So my inventory items consist of an item definition. Oops. There it is. Item definition coupled with an item instance. Now these properties of these two classes, that is what an item is in my game. And it's the same with containers. That's what a container is in my game. And that's the instance data that is generated when I create a new container. So I'm not duplicating information. These are all separated out. And that's, in my opinion, that's a good design. Static data from instance data, separating them out. So the JSON files, are loaded into dictionaries, and going back to my inventory engine, you can see up here at the top that I have my item definition dictionary, I have my container definition, and these are storing the class objects into the dictionary, this item definition dictionary, based on the item definition JSON file. So these all get loaded into those various dictionaries. So these are my definitions, these are my instances, and I even do the same thing with my textures. I load my textures for all of my inventory items in a dictionary. And then I call into that dictionary when I want to pull out an image to use in the UI. Okay, and that's what it's all about. Trying to minimize the amount of data that you're moving back and forth in the in your implementation, whatever that implementation is. Now let's take a quick look at the code for my nodes and just take a quick peek at that. All right, here we are. Let's start at the bottom, the inventory slot. Now the inventory slot is what's going to hold the image that's going to be shown when the inventory item is added to a container. And so it is, in my particular implementation, I'm inheriting from the center container, Godot's center container. And basically, I have access to my inventory engine via a private instance of this inventory engine. I also have access to an inventory engine, or excuse me, inventory window manager. I have my background texture, the quantity. I mean, this is just basically how I implement it. In my ready, I grab everything that I need. I set up everything. My slot graphics. Remember, I said that the UI was data driven. So if you look at my slot graphics, I'm basically um, checking the slot size of the container, and I'm setting everything up based on what slot size it is, and pretty much, grabbing the setup of the graphics themselves. And and then of course I've got this is my drag and drop. And I'm going to do a separate video on drag and drop because in my drag and drop implementation, I'm actually dragging and dropping a custom piece of data, a C# class. Okay. And I'll show you, I'm going to do a video on how to do that because there's a lot of confusion on that I've seen on Reddit and other places where people don't understand how to handle this drag and drop properly. So the inventory slot basically is responsible for pulling in the inventory or the information from the inventory engine just enough to display what it needs to display in that slot. The inventory window does exactly the same thing. It's only pulling the slot data that it needs. And so after I set everything up, I create my container slots, and it's all data driven. Um, so you'll notice here that I'm doing a for each over the container definition, small slot count, and then I am instantiating those inventory slots. That's the child node, the slot node, the scene. Um, and I am instantiating it. I'm initializing it. That's a method that I created to pass some data to it. And then I am setting the name, and then I am adding it to the parent container. And I'm doing the same thing for the medium slots and the large slots. And so this is where I'm trying to calculate the panel size. And uh, rather than I'm rather than you understanding what I'm doing here, I want you to understand the concept, the principle. And this video is about the principles of design. Okay. The important thing is that my code that sits in my window, I have 320 some lines of code here. Okay. It is tapping into the inventory engine to get what it needs. I'm not, you know, storing my labels data in the UI, the window UI, so that I can um, iterate through all the possible inventory combinations I had. No, all that's back in the singleton. That's where it belongs. It doesn't belong in the UI. Okay, so looking at the inventory slot, we're looking at 200 lines of code. In the inventory window, like I just said, we've got 300 lines of code. The inventory window manager, all it does is basically tell the inventory window to fire off and do its thing. Yeah, so we're looking at just a couple of hundred lines of code. But the inventory engine, that's where everything is happening. That's where most of the work is being done. And that's the kind of design you want in your inventory system to be able to make it powerful and flexible and extensible. And I will, I will, I think I've run pretty long. I'm about 50 minutes here on this video. I, I think what I'm going to do is wind down, and I do want to kind of show you the workflow. For example, like how do I add, let's say I want to add a, a new instance of an item for in my dev window back here in this window here. I want to add something. Oh, you know what? I'm going to show you two things real quick. I'm going to show you how this design makes things really easy to manage, okay? This dev test window is a container. It has 4 large slots, okay? It has 6 medium slots, and it has 20 small slots. Let me show you something. I'm going to go to my JSON file, if my eyes will let me find it. Container definition. If we go all the way up here to the top, this is that dev test window, okay? It has 20 small slots and 6 medium slots and 4 large slots. I'm going to change the large slots to 2. I'm going to change the medium slots to 4. I'm going to change the small slots to 16, okay? That's all I did. This is what good design allows you to do. I'm not saying my design is the best design. I'm just saying the way I've designed it, this is what I can do with this design. All I changed was the JSON data, okay? That's it. That's all I changed. Now, why does it look weird and wonky there? Well, because some of the JSON data I didn't change, and it's just following the rules. Okay? Let's take a look at why it loaded the way it did. Okay? If I go back and I look at my definition, I see that I have these slot counts, but I also have these column counts. See? So I'm saying, hey, for those small slots, I want 5 columns of slots in the UI. Let's bring it down to 4. The medium slot count, how many medium slots do I have? I have 4. Let's divide those 4 into 2 columns. And the large, well, I only have 2. Let's break that down to just one column. Okay. So this data, this JSON data, this definition is working together. The UI is using this data to build that layout the way it needs to look, or the way I want it to look. This provides a whole lot of flexibility in how you define and what your windows are going to look like, what your containers are going to look like. So if I open this now and I look, now that looks a lot better. That layout is much nicer. 2 large, 4 medium, and 16 small. And that's good design, to be able to use data to change the design without changing code. And I'll tell you something else. That concept of separation of concerns that I talked about earlier, I am designing this in such a way that I hesitate to use the word because some people are going to say I'm not really using this design principle, but I am. It's just that this is not an in-tier application, so I don't have to follow the design in the same way that you would with an in-tier application. Those of you that know what I'm talking about know what I'm talking about. I'm trying to apply clean architecture principles in my development, meaning that if I change something over here, something over there isn't going to break. So just because I changed the definition of this window, the definition of the window did not break the drag and drop functionality. It did not break my tooltips. It did not break positioning. It did not break anything. It did not break my sorting. It didn't break anything. And that's important. You want to isolate your code and let um, good code does one thing well. Okay? That's another principle of design and principle of software engineering. Let your methods do one thing well. Sometimes it's hard to do that. Some, you want to have a method that does 55 things. Sometimes it's really, really hard to resist the temptation to throw it all in one method. And I'm guilty of it as much as anyone. But good design is that each method in your class does one thing well. Does it well. It is the subject matter expert of what it does. And that's good design. Okay, so the other thing I want to show you before I close is I want to go back, take a look at my engine. And I think what I want to do, let me go to my item definitions. And I'm just going to just visually, I just looking through some stuff here. Let me add some buckskin breeches to my test data. Okay, the key to that is 44. If I go to my inventory engine, the key is 44. So here's my method that does one thing well and creates test objects. Okay, so 44. So that's an item. Just do some copy and paste here. 44 was the item. I'm going to drop it into the player inventory. It is of type item. Its key is 44. Its quantity is 1. And it's going to go into the player inventory container. And this is breeches. All right. I'm going to save that. I'm trying to think, do I have enough slots? I think so. Okay. If not, it'll drop it on the ground. But, well, it'll drop it on the ground when I finish the coding for dropping on the ground. Haven't done that yet, but that's the intent. All right, so let me jump over here. Okay. All right, there they are. How did they know to go in slot numbered the medium-sized slot? Well, because the definition said buckskin breeches belong in the medium slot. Okay, and so these definitions. See, I'm leaning on my static data that defines what these things are. And that is good design. What did I change? I changed one line of code, and I only did that because I'm embedding some test data in this dev test container. That's all I did. I loaded the JSON with the definition. I added previously to this video, I added the buckskin breeches to my list of PNG files, my images for my game assets. The PNG file itself, I defined what the buckskin breeches was by making it an item and not a container or a liquid. And I defined the properties of that item, both its definition and its instance data, what it looks like. And so by doing that, I was able to just simply add it in. Now, when I get to in Godot 3, I had made a crafting engine, and I'm going to implement that here, but it's going to be just like I did with my inventory system. This inventory system is leaps and bounds better than the previous one. And that's another great thing about software development. The more you do, the more you learn, the better you get, the better things you make. I guess that's why I love it. I love software engineering. But I put a whole lot more features into this new version of the inventory engine, and I'm going to do the same for the others. But anyway, lost my train of thought and all the wonderfulness of software engineering. But anyway, I was able to add it here, and I know what I was going to think. I know what I was going to say. This whole thing, create test objects. This create test objects is a method I'm using for testing. Okay, but this craft new object is the foundation of my new crafting engine, because inventory and crafting are kind of hand in hand. And even my inventory engine, what I call inventory is going to expand out to a whole bunch of areas of the game. Because if I can use this same system for a crafting window, or, and I'll kind of I'm going to wind down here with showing you this. If I can use this crafting engine to support my player inventory, then the drag and drop functionality would be automatic, and this would just become another window in my inventory system. And I won't get into it in this video, but the reason, or this window is actually a one-off. What I mean by that is I've designed this with more code in the UI only because this is not the same as this window. These are two different scenes. These have fixed position um, slots. These also have different size slots to accommodate the look and feel that I want in my accoutrements, which is going to be the player inventory for this game window. I wanted it to be different. This is uh, data driven for the UI layout. This is fixed UI layout, but they both use the inventory engine. They both use the inventory window manager. They both tap into a lot of the same things. It's just the UI looks a little bit different. And when I get around to making my crafting window, it's going to be a a one-off implementation of the UI with utilizing the inventory system itself. All right, I think I'm going to stop there. I hope you have learned something today. If you have any questions or comments, please post them down in the comments section. If you liked what you saw today, if you want to see more videos like this, because honestly, this is a hobby for me. I don't produce a ton of videos because I'm not trying to make a living off of YouTube. I'm just trying to get some information out and talk about my game and enjoy what I'm doing. This is a hobby, so this is part of my hobby, making these videos. But if you got something from it, and you haven't subscribed, I encourage you to do so. And if you like it, give it a thumbs up. And until next time, I'm bound to be coding.